How's it going, everybody, and welcome back to our Cisco Enterprise series where we continue our section on MPLS Layer 3 VPNs. In this video, we're going to be specifically focusing on the verification process of MPLS VPNs. And the reason why I feel like we need to do this, well, not feel, I know, is real simple. If you know what known good output looks like, then you will be able to quickly discern known bad output or a misconfiguration, whether it's been configured incorrectly or the configuration is missing altogether. So that is the intention here with this video, is to walk you through all of the details that are required for you to get this entire environment up and running. So we're going to be looking at all 5 layers of the layer cake, right? We have the first 3 layers, IGP, LDP, and BGP, VPN, v4. Then we have layers 4 and 5, which is VRFs and PE to CE routing. Assuming that we have all of that done correctly, we should have end-to-end connectivity. We know we do because in the previous video we got it all stood up, so we know it's operationally correct. So in this video we're going to be focusing on those details. How do we verify each piece of it in order to make sure that things are working the way we expect them to? So before I dive into what those are going to look like, we really need to just understand the components review, right? We have core IGP and LDP on PEs and P routers, VRF PE to CE, PE to CE routing, VPN v4 BGP between PEs, VRF to VPN v4 import export, and data plane communication. If those 5 things, so we have 1, 2, 3, 4, 5, 6, 6 things. So from an operational perspective, we want to look at this from start at IGP, right? Now, one of the first things that I'll do before I do anything is do a show IP Ceph to make sure Ceph is enabled. If Ceph, Cisco Express Forwarding, is not enabled, then LDP won't be able to work the way you want it to. So there is a show IP Ceph, then you have your IGP verification. Show whatever the IGP is. In this case here, it's show IS to IS interfaces, show IS to IS neighbors, show IP route IS to IS, things like that. And then we have our MPLS LDP configuration. So again, what interfaces are enabled for LDP, what neighbors will be formed via LDP, what does our label distribution table look like, what are our bindings, and then what does the label forwarding base, the forwarding table look like. And then I'm going to jump down here. We have VRF PE to CE verification. That to me comes later. So we're going to jump down to VPN v4 between PEs. So did VPN v4 BGP established? Show BGP VPN v4 unicast all summary. You can debug it to see this in more detail if you'd like. And then VRF to VPN v4 import export verification. So you have your VRF config. Did the correct route target import export values get done? Did IGP to BGP redistribution occur? In the event if you are using a IGP as your PE to CE routing protocol, that's where this would come into play. And then are VPN v4 routes being sent and received? So you have all of that information to go over. Data plane verification, can you ping, trace route, telnet, etc. So now we've gone over those details, let's go ahead and do this from a ground up perspective. So we're going to bring this up and let us take a look at the verification piece. So again, we're going to start on, say, 30. And I'm going to do a show IS interfaces. Show IS. IS neighbors? Or I'm sorry, show CLNS interfaces. So we know that gig 00, 1, 2, 3, 4 are all enabled. Show IS neighbors. We know we have neighbor adjacencies everywhere. That's good. And then do a show IP route IS to IS. And we want to make sure that we have /32 routes in the routing table, which we do. So now we verified IGP. Now, one could say, would you really want to do those 3 commands on every device? Well, the reality of it is, you can verify 3 things right away if you do it correctly. So you want to do an IGP verification, a VPN v4, or in this case here an LDP peering. And the fastest way to do this, and this is what I did in the lab exam myself when I was doing the troubleshooting section, was to go in here, do a show IP route, look for the remote PEIP, so 65, 10.0.0.65, so trace route to 10.0.0.65, sourcing from loopback 0 numerically. Do I have a labeled path? Yes, I do. Do I have end-to-end reachability? Yes, I do. What that simply means to me, if I can trace route back and forth, normally I would ping first and I would trace route. If those things came back, that automatically verified IGP and LDP in one fell swoop. So I was able to knock out that verification right away. And what I would do, since I was already that close, I would make sure that I would take that path, do the same thing for everybody else. And then I would do for 46, even though I know it's one of those things where I know it's going to work, everything looks correct from that perspective. So that's how you verify very, very quickly. And you know it's operational. So from there, you know you're in a good spot. So then it's a matter of, okay, let's verify VPN v4 and go from there. So what would you do there? Show BGP, VPN v4, unicast, all summary. I'm learning 5 prefixes. So from 32 and 47, I'm learning 5 prefixes. If I hit the up arrow, pull the summary out, I'm learning a bunch of routes. So as far as I'm concerned, everything is doing what it's expected to do. Everybody's happy, right? And that's the key thing. So I just verified that there's route propagation everywhere in the network. And then you have your PE to CE routing. So if you do a show BGP VRF A IPv4 unicast, show BGP VRF A VPN v4 unicast, sorry, summary, you can verify that we have a peering up and then we have learned routes. We can see what routes are coming in there. If you want to dig into the details of that, show IP route VRF A, and you're going to see the routes that are being learned. So we just, in just a couple of minutes, have been able to verify a lot of detail about what the environment has. And now if you want to take that a step further, you can go over to switch 17 and do what we did earlier in the previous video. At the end of it, we can do a show IP route. We have some external routes in the routing table. So we can do a trace route via IP to 10.18.30 or 10.18.12.18 from 10.17.12.17 numerically, yes. And so we should be able to trace route to that destination, which we can. So that right there, if I have end-to-end reachability, it would work out. Now, in the event that any one of those outputs that I've done from the very beginning, whether it's an IGP verification, an LDP verification, verifying a BGP VPN v4 has a peering. If you take it the next step and you try to verify the VRF routing table, and then you take it to verifying that there is a BGP peering inside the VRF, and then you take it the next step and you verify the CE side. Can the CE devices see each other's routes? If you're taking it at each one of those levels and everything is working out, that's a good sign. However, if there is an issue at any one of those levels, it's very easy to identify what the problem is. Because then all you have to do is simply go in there and make sure that the configuration is correct. Then it's if you can identify which particular layer of the cake is missing, or there's a misconfiguration or a lack of configuration, whatever it might be, then you'll be able to dig into it more deeply. Now, I'll give you an example of what I mean by that. So if we go to, sorry, not on 17, if we go to 64, let's go to 64 and do a show run pipe section VRF. What I'm going to do is I'm going to change the import policy to 10:11. And before I do that, I'm going to do a debug BGP updates. BGP VPN v4 unicast updates. Now, so I'm going to type in VRF definition A, and then underneath here, I'm going to say route target import. 10:11. And then I'm going to, I'm going to let that do its thing. Do show run pipe section VRF. I'm going to go ahead and say no and get rid of this route target value. Okay, so that's what that's going to do, is it's going to flush. It should flush the routing table. Denied, yep, there we go. We're going to let it finish doing its thing. Okay, so now if I do show IP route VRFA, I am not receiving any routes from anybody. I'm receiving routes from 37 because we can verify the next hop. And if I do show BGP VPN v4, VRFA, VPN v4 unicast all sum. Right, I'm receiving routes, but I'm only receiving routes from 1017. So it means I'm getting routes in from here, but I'm not getting routes in from over here. Now, one thing that I want you guys to be cognizant of is if you look right here, this right here is a clue. Pay attention to this. If you see this at any point in time, if you see denied due to extended community not supported, that is a clear indicator that you have the wrong route target or no route target set. That's why I wanted to show you this. This is one of those things where it's different from the route distinguisher, right? So you're not going to inject or you're not going to import those routes from the VRF or from VPN-v4 into the VRF because you don't have the correct route target value set. So I turned it off, and I changed the route target value, right, from 10:10 to 10:11. That breaks it. So this is one of those things where going back to this, if you know what good configuration looks like, a good output, you got to configure correctly, and you go through the individual verification steps. A lot of it's going to be pattern recognition after a while, but if you do enough of it and you spend enough time doing it, this will become very, very obvious to you. So what we did is we come down here is we modify the import-export policy. So I went in specifically the import policy and said, I don't want to import the correct route target. I'm going to import the wrong route target. It could be a misconfiguration. It could have been a simple fat finger, for all we know. You might have just hit 11, the 1 twice, except by accident, not the 1 0 to make a 10. Legit potential? Sure, possibly. But it's one of those things where if you know what to look for, and if you're debugging it, it'd be very, very easy to tell. So what I'm going to do is I'm going to go ahead and fix that. So if you were going back and forth and you were looking at the outputs, you're like, well, this isn't right. How come this isn't coming through? How come I'm only getting a handful of routes? Stuff like that. Because the fact that you know what good config looks like, you'd be able to do a do show run pipe section VRF and go, okay, 10:11 is your import. And what I would do is I would go, the likelihood of whoever writes there's no dedicated troubleshooting lab anymore, or troubleshooting section to the lab exam anymore. But if you're in a situation where you're dealing with, let's say, 5 or 6 routers in an MPLS VPN environment, the likelihood of them configuring faults into every router is pretty unlikely. However, it's not impossible. So your job is to be able to identify, based off of the outputs you're looking at, what that potential issue is. So I'm going to go ahead and move this back to route target import and say a 10:10. And because I'm going to do that, we'll see that we're going to accept the routes, and everybody's going to be okay. Okay. Now, I'm going to go ahead and pull this other route target out. because I don't need that there. And it's going to go ahead, and every time you make an adjustment, it's always going to go ahead and do a full resynchronization of the table. It's part of BGP, so just deal with it. So we have all that going for us. Everything looks good there. Don't worry about the denied due to originator is us. Don't worry about any of that. So that is no problem there. All right, so now that we've verified, giving you an example of what that would look like, now you're more informed. So because of the fact that it's not as simple as router OSPF1 and then just verifying that you have a particular feature turned on or off or what have you, MPLS is multiple individual technologies coupled together in order to make something work. That's how the service operates. So you have to be able to troubleshoot at every level of MPLS. So, and those of you that are studying for your NRC exam for CCNP, this is the likelihood, because the exam, if you look at the exam topics, it does state that you should be able to describe MPLS VPNs. So I don't think they're going to actually troubleshoot you or have you troubleshoot MPLS VPNs in an RC, but I could totally see them do some sort of troubleshooting scenario inside of the CCIA lab where you have to figure out why it's broken. So, but that's one of those things where if you know what a good config looks like and what a good output looks like, then you'll be able to go, that's not the way that's supposed to be, or understand how the debug output looks. If you can read through the debug and understand what that means, I mean, this right here is a clear indicator. This is the one thing that I paid attention to a lot when I was studying for the exam. I wanted to make sure if I found this, that I'd be able to, I knew exactly what that meant. Now, I'm not saying that's what I got in the lab, but when I was testing out, and there was a couple of individuals that I was in a study group with, and we would basically write our own bugs, or I should say, we write our own faults. So we would write labs for each other, and that person would, input faults for us, and it was our job to identify them and fix them. But the funny thing, here's the interesting thing about the CCIA lab, at least the one that I took, or the version I took, I should say, is simply knowing out, typing in no in the front and negating the command. Simply doing that was not sufficient enough to resolve the ticket. You couldn't remove configuration. So I remember that very clearly in the troubleshoot. You could not remove configuration. You had to be able to solve the issue without doing removing any config. And I do remember there was I don't remember exactly how to do it, but there is a way in iOS to do show running config pipe something. There's a way to do the amount of lines to check it. Show running config line number brief. So you can, what you can do is you can go through and it will look like there's a script that obviously grades your tests for you. Where if you couldn't remove a line of config, because if you removed a line of config, your number would stop. Instead of being 193, it'd be 192. So if you were to go in there and remove a line of config, it would automatically be able to detect that, and you potentially would have broken a restriction. So it's one of those things where you just got to be cognizant of stuff like that. So if you ran into that particular problem, your job wouldn't be to remove the config, it would be to modify the configuration in order to solve the problem. So that might mean that you might need to go, if your verification said, I don't know, I'm completely spitballing here at the moment, but let's say, for example, your config was supposed to say that you're only supposed to allow /32 loopbacks in your MPLS table, so show MPLS forwarding, right? You want only /32s to show up, right? You don't want any of this /24 business down here, right? You don't want any of this stuff right here. Well, there's a way to make that happen, but if you're doing it, or you've got to. There's ways of making stuff happen, and I was trying to think of a good way of doing that, but off the top of my head, I can't think of one. But the bottom line here is, it wouldn't be out of the question for you to have to go modify an access list or a prefix list or something along those lines. In most cases, you're going to deal with an access list if you're dealing with control plane protocols. Modify the access list to get the job done. So you wouldn't be able to say, or remove the access list by deleting it. But again, there might be a line in there that says, do not delete any lines of config. You have to modify it. So deleting and adding are two different things. So that's one of those things where the deeper you get into the lab prep, the more interesting it gets. So that's just one of those interesting things I do remember about the exam. So with that being said, we went through and we verified the operations. We understand how it's all put together and all that type of stuff. So the key thing that I want you guys to remember is, at the end of the day, your goal is to be able to provide a solution to a problem. That is your goal at the end of the exam. The one thing that I think everybody, especially for anybody that's a CCIE candidate, that the exam is not best practice. That's one thing that I had to wrap my head around early on when I was prepping for it. It's not best practice. You're going to be asked to do stuff in the exam that you would never do by default as a de facto standard. You would never do that particular thing. And ironically, I learned over the course of my career that just because best practice is best practice doesn't mean you have to follow it. So there might be scenarios where you have to do things that are unorthodox, get to do something in order to get something else to work, or you have to jump through a hoop and, the validated design says to do things A, B, C, 1, 2, 3, but you can't. You have to do it B, C, D, 2, 3, 4. In order to get something to operate the way you need it to do its job, you have to go outside of best practice to get the job done and to get the solution to work. So being out of the box definitely helps. An out of the box thinker definitely helps. So with that being said, ladies and gentlemen, that is the verification process that I wanted to walk you guys through. We will be definitely taking a look at other variations of this as we move forward in the future. As you can see, I haven't updated the rest of the topology yet. A lot of stuff is still powered off, but I wanted to get this video out of the way so we can just verify basic stuff. The cool thing about the verification that we've gone through thus far is the key thing is that it doesn't matter the PE to CE routing protocol. If you add an IGP or static routing to your PE to CE routing practice, if that's going to be, you're going to be adding that in, then everything else still gets verified the same. Your IP or your IGP in the core, LDP in the core, BGP, BP, and B4 in the core, all that stays the same. VRF has to be configured appropriately. The only thing that could go outside of the norm and beyond BGP to an IGP or static routing would be PE to CE routing. So then if you are dealing with that, which I encourage you to play around with just so you know what the steps are, so in the event that you get tasked with doing something like that, you're in good shape. So that is one of the things that I definitely suggest you guys go out and do is make sure you know what all the different variations of the configuration could look like. So the more you practice, the better off you're going to be. With that being said, ladies and gentlemen, that is everything that I have for you in this video. If you haven't already done so, if you have any questions, comments, concerns, feedback, drop that in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video. Have a good one, everybody.